Hello students, welcome to Physics Pathshala. Today we'll study the leftover part of significant figure. As we have discussed, significant figure is the results of measurement or accepted measured value. It is very nearer to the true value of the quantity, true value of the item we want to measure. We have studied quantity is a term in physics which can be measured. That means in place of items we'll be using quantities in physics, and amount of quantity that we want to measure will have its own true value, that is the exact value, and which is the measured value. The measured value is what we have come to know after measurement using certain instruments. This measured value, when deviates from its true value, there is a difference, and this difference is the error. When measured value will become equal to true value, in that case we will say it has nil error. But uh, there will be certain deviation of measured value from true value, hence error will be associated with all measurements. Now, our purpose is this error should be as less as possible. For that, we have identified one number, that is significant figures or significant digit, that will very nearer to true value. In that case, error is very less, and this significant figure came after including the certain digits plus first on certain digit of measurements. That means when we do certain measurement of any item, we'll have certain fixed or reliable digit plus a number of uncertain variables, unreliable digits. These unreliable digits will give different values in different measurements. This is the root cause of error. In that case, suppose we have number of different unreliable digits followed by certain digits, then all certain digits plus first uncertain digit will be included in our measurement as a result of the measurement, and this will give to the significant figure. That means, where summarizing, we came to know once we do measurement of any quantity or any item, will in result we will have certain digits which is fixed like 1, 2, 3. After that we will have a lot of uncertain digits, let it is 6, 7, 8. Here these are all uncertain digits, right? Then what we'll do, we'll take these certain digits plus first uncertain digit. That means it will become like 1, 2, 3.456. This will be our significant figure. To find out significant figure, we had certain rules to identify these significant digits. Suppose after measurement, the result given a number that became like 102, 123.023, 123.030, 123.0, 123.023, 0.12300. We'll have certain rules we have already studied. First, we have four rules. First rule says all non-zeros will be significant digit. Non-zeros in this case, 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 all these non-zeros will be significant digits. Next is all zeros between non-zeros will be significant. That means this zero between two this non-zero, this zero between two this non-zero, and this zero between two this non-zero will be significant. Third says all leading zeros, all leading zeros, whether it is decimal number or non-decimal number in both case, like in both case non-zeros, whether it is decimal number or non-decimal number, in both case it is non-zeros are significant digits or figure, and zeros between all non-zero digits will be significant digit in both decimal number, non-decimal number. All leading zeros will be non-significant digits in both decimal number and non-decimal number. Now, that means all leading zeros means starting zero, leading or starting zeros. Here, in this case, all these will be non-significant. Now, the fourth one is terminating or trailing zeros. Trailing zeros or terminating zeros. That end zeros. That means zeros to the right of the number for decimal number it will be significant, whereas for non-decimal number it will be non-significant. Now this is the decimal number. Here in this case it will be significant, whereas for this non-decimal number it will be non-significant. Now after using all these fours, this number will have 1, 2, 3, 4, 5, 6, 6 significant digits. In this case it will be having 1, 2, 3, 4, 5, 6 decimal digits. In this case, 3 decimal digits. In this case, we'll have 1, 2, 3, 4, 5, 6 decimal digits. In this case, 1, 2, 3 as significant digits. Now, a composite quantity, that means like a quantity depends upon other quantities. Here we say derived quantities. Such volume is given and mass is also given. When we find out density of any item, that is mass divided by volume, in that case, what we do, suppose you have the value of mass, let it value is um, given. Now let value of mass of an item is given, let 4.237 gram, and its volume is 2.51 centimeter cube. Then its density will be mass per volume. It will come like 1.68804780826. Like I said, a lot of numbers after, a lot of digits after decimal point. This will give us an irrelevant result, or it will be a very absurd one. Now to come to, for our usable, we need to find out how many digits will be taking after this decimal. Normally you used to take 3 decimal places after decimal point. In this case it will be 1688. Now what we will be doing, for rest numbers, instead of 8 it is, we write 9. It became 1689 gram per centimeter cube. To come to this conclusion, in our result it involved division. If any result involves division or multiplication of two different quantities, that means if any quantity to be measured involves division and multiplication of two other different quantities, then in that case the final significant figure of the measured quantity will be refers to the least significant figure. Least refer to the dependent number having a dependent quantity having least significant digits. That means if this is our final quantity and that came after division of two different quantities, in this case it is volume, in this case it is our mass, and sorry, in this case it is our density, and dependent quantities were mass and volume. Now we had significant figure of mass, we had significant figure of volume. Once we will calculate significant figure of density, this will link to the significant figure of the dependent quantity having least significant figure. Least significant figure. That means here we had in significant figure of mass is 1, 2, 3, 4. Significant figure of volume 1, 2, 3. Now the result will refer to significant figure of volume because volume has less significant digits or least significant figure. In that case, once significant figure of volume is 3, significant figure of the density will be 3. Now, in that case, instead of going in number of digits after decimal place, we'll be going up to 1.69. We'll be writing. Correct? In similar way, suppose three numbers are given and all are added, the resultant be will be after addition in number of digits after decimal point. Now it is incorrect to take any decimal digits in arbitrary way. For that, here in this case, the result after just normal arithmetic addition, it will be 3 decimal digits, 3 decimal, it will have 3 digits after decimal points. But already one term has only 2 decimal digits or 2 digits after decimal point. That means it has already more precision. Now we cannot go for less precision in our result. Once we have after normal arithmetic addition, this is our result, we got it. Now in this case, one digit already had very less significant digits, that means up to 2 places, and in our result now we have 3 uh, 3 digits after decimal points. It shows it is less precision as we have more significant digits. As we have more significant digits, already we have less significant digits in our one item. In our result, it should be less one, so that we summarize, we came to know or we accepted that to have this less one will refer to the number having less significant or less, in this case we will be referring to less decimal points, less decimal digits will refer to less decimal places. Now we came to know while doing division or multiplication of two quantities, the resultant one will be referring to the quantity having least significant figure. While doing addition or subtraction, the final quantity will refer to less decimal places digit. Less decimal place, or the number having less decimal places. That means less decimal place will be the key factor while doing addition and subtraction, and while doing multiplication and division, least significant figure will be key factor to find out the results. Now we had significant figure that constitute a number of digits in the number, let it 1, 2, 3, 4, 5, 6, 7, 8. What do we do? Suppose we have, this is our certain numbers, certain digits, and these are uncertain digits. Our significant figure constitute if this is a certain digit and this is uncertain digit, significant figure become 1, 2, 3.4 and 5. Now what happened? We have a number of uncertain digits after that, which we are just ignored. But to have more accurate significant figure, what we have done, we have rounded off the last significant digit. Now what we'll do, rounding of the we'll rounding of the significant figure to its least significant digits. Now significant figure will be rounded off for more precision of in our results. That means, suppose for example, if length is given and volume will be 3 times length is multiplied, and we'll get a very big huge number like this, and we'll have a number of digits after decimal points. Whereas in this case length has only 1, 2, 3, 4, 4 significant digits. In this case we have a number of digits after decimal points, whereas we expect this result also should have the same significant figure or 4 significant digits. In that case it will be coming up to 0.7 and all other will not be in our results. Sometimes what happen, this number, if it is more than greater than 5, then what we do, we just change this number and get our correct significant figure or significant digits. Now, depending upon this number, whether it is greater than 5 or less than 5 or equal to 5, we will determine our this previous number and find the exact correct significant figure. This is a rounding of the uncertain digits. In result, suppose we had these digits 4, 5, 6, 7, 8. Another digit you have 1, 2, 3, 4, 5, 1. Another digit you have 4, 5. Suppose it 4, 7, and 5. Now, in all three cases, suppose this is our first uncertain digit and rest are followed by them. Here in this case, this is first uncertain digit, and in this case, this is first uncertain digit. Now, this will be converted to 1.3, 1, 2, 3.45, and one number. This will be converted to 1, 2, 3, 4, 5, one digit, 1, 2, 3, 4, 7, and one more digit. Now, question is whether this 6 will remain here or not. Once 6 is greater than 5, we have categorized this result into three categories, whether the second uncertain digit is greater than 5, second uncertain digit is less than 5, or equal to 5. In this case, second uncertain digit is 7. Here in this case, it is okay. In place of this, if this number will be, let it is 7, and it is 2, and it is again 5. What will, how will calculate? Here it is 7, here it is 2, and here it is 5. This is greater than 5. In that case, what we will do? We'll just drop it, and we'll add this with previous number with 1. If this second uncertain digit is, now our number will become 4, 5, 6. In place of 6, it will become 7. That means if the second uncertain digit is greater than 5, the previous one will be added by 1 plus 1, and it will be dropped. In second case, if it is less than 5, will simply drop, and previous number will remain as it is. In third case, it is equal to 5. Then we have to see the previous digit is whether odd or previous digit is even. Here we have to concentrate, we have to make it even. Goal is to make previous number as even. If it is odd, then add 1. If it is even, simply drop. This is the case like greater than 5. Earlier, once the digit was greater than 5, simply it was dropped and previous digit was added with or increased by 1. Here, in this case, if the previous digit is odd, then in that case, what we will do? we'll add 1 to previous case and this digit will be dropped. That means this 5 was there, 1 will be added and it will become 6 and this will be dropped. Suppose another number is there 7, 2, 5, 3. In that case, it was previous number was even, so it will simply drop and no addition will be there. 1, 2, 3, 4, 7, 2. Now summarizing significant figure. First we came to know this is the accepted measured value. It is very nearer to our expected value. Second thing is significant figure will include 4 rules to find out its significant digits. Third is will be while we will be doing mathematical operations, combinations of different quantities for subtraction, for division and multiplication, will refer to lowest significant figure digit, significant figure or significant digit of the quantity. That means the quantity having less significant figure will play the key role and final result will have the same significant figure. Where addition and subtraction of different quantities, the resultant will refer to lowest decimal places of the number. That means it will refer to the quantity having lowest decimal places. If any dependent quantity has lowest decimal places, result will have that much decimal places. In division and multiplication, resultant will have, if any dependent quantity has lowest significant figure, resultant will have that same significant figure as the lowest significant figure quantity. Now the fourth one is rounding off. Rounding of significant figures. Rounding off of significant figure or uncertain digits. Rounding off of uncertain digits. In this case, we found out the second uncertain digit if it is greater than 5, if it is less than 5, and if it is equal to 5. Here, if it is greater than 5, second uncertain digit will be dropped. Second uncertain digit will be dropped. If it is less than 5, again second uncertain digit will be dropped. If it is less equal to 5 also, second uncertain digit will be dropped. But the previous digit, previous one, here plus 1 will be added. Here no change. Here we have to see whether the previous digit is again, if it is odd, we have to make it even by adding 1. That means add 1. If it is even, simply no change. This will be case odd, means case like greater than 1. If it is even, it will be case of less than, sorry, if it is odd, it is a case of greater than 5, and if it is even, it is a case of less than 5. With this, we have covered our significant figure. In next class, we will study what are the errors involved in measurement. While doing measurement, what are the errors will be involved, and what are the types of error, and what will be mathematical operation or combination of different quantities having errors, what will the result error of final result.